Welcome to qnawire.
So for this problem, we have a transformer and the source has 120 volts. So basically we have this source and it is connected with a transformer. So this is the transformer, okay? And this is a secondary circuit. In the secondary circuit, we have a resistor, R, and the resistance is 5 ohms. So for part A, we want to know the ratio of the prime to secondary returns of the transformer. So because we already know that the power supply has 120 volts and it supplies 12 volts in the secondary circuit. So basically NP over NS, so primary over the secondary equal to VP over Vs. So this is the voltage in the primary, this is the voltage in the secondary. So in this case, just equal to 120 over 12, so it's 10. So the ratio is just 10. And for part B, so we want to find out the current in the secondary circuit, because we already know that the power supply in the secondary circuit is 12 volts, and we also know the resistance is 5 ohms. So the current is easy. Just use the Ohm's law. So it's 12 volts over 5 ohms equal to 2.4 amperes. Okay. And for part C, so we want to find out the average power delivered in the load that is delivered in the secondary circuit. So we already found out the RMS current in the secondary circuit, and we also know the power supply in the secondary circuit, that is 12. So the P average simply equal to V RMS times I RMS, and this V is this 12 volts. Okay. So just use 12 times this 2.4. So let me see what the result is. 12 times 2.4, that is 28.8 watts. Okay. And for part D, so what resistance connected directly across the 120 volts line would draw the same power as the transformer? So let me see, across this line would draw the same power as the transformer. So I think it's just like we have this power supply S, and it's just connected with another resistor directly or primed, and this power supply has the power supply is also 120 volts. So we want to know what this R prime is if the power in this circuit is the same as the power in this circuit. I think this is the meaning of this part. So the power in the new circuit is simply P primed equal to 120 volts squared over R primed, right? So this is the power in the new circuit, and it should be equal to the power in the original circuit. It's equal to 28.8 watts as we obtain here. So we can solve for R primed. It equal to 500 ohms, right? So we show that this is equal to 5 ohms times the square of the ratio of the prime to secondary turns. So 500 equal to 5 ohms times 10 squared. 10 is the ratio, right? So this is proved. Okay.